Good morning, guys. I'm bersipy, and today we are going to make something different. We are going to start a new fresh run in The Farmer Was Replaced, which is a game about automating a invisible farmer with your drone. And this drone is will be programmed in Python. So here we are. All right, first program. We can do everything here. We don't need an external IDE or text editor. We can actually set the external editor, but it is not mandatory. Okay, we can create more files using the plus button. By the way, this is our little drone, and this is our money, I don't know, money bank, and okay, there is a code completion. We can press tab to actually autocomplete keywords. All right. Okay, currently we have only harvest and do flip. Do flip is a function probably useful to wait, just to wait. Let's make it. Let's make this. We don't have probably a loop right now. I don't think that we have a loop, but we will actually launch this program n times. Wait. Okay, I needed to wait that the actual grass grow. Completely grow. All right. This is boring 10 times. Okay. And now we can unlock something, right? What I've locked? Okay, the while loop. So we can actually just do this shit here. Yes, wait, true. Okay. Okay, we have the condition, which is true in my case. All right. Let's see the next unlocking block. Okay, for 20 grass we can get the speed. We can increase the speed or get the increase the yield of the grass. Let's increase the speed. Okay. And we can actually expand our farm. I think we'll increase in one row, one column. I think. Don't know. This game is awesome, by the way, because I think mostly for the graphical user interface, but yes, is a good introduction to Python, I think. Yes, we have also can harvest. So probably we can just remove the do a flip, and we can just check if can harvest to speed up a bit. Yes. Okay, let's expand our farm. Okay, now we have a new method, is move, which accept an argument, north, east, southwest. So, okay, let's implement the movement. North is a constant, right? It's a global constant that the game actually gave us. All right. So actually, when I reach the end of the y-axis, I think I restart from 0. Nice. Okay, we can unlock planting. We can plant the bushes. So we have unlocked also the bush. Okay, we can call clear. Actually, clear can be useful to start always from a clean situation. Right. right, entity.bush. Let's try. Probably for a timing reason should just work, but I'm not sure. Let's see. Okay, this is actually wrong, by the way. All right. Okay, so the plant actually works only if there is if you can plant. So we can actually trust the fact that the plant will not overwrite our actually growing plant, right? By the way, we are collecting wood, and I think we can actually increase the speed, for example. Yes, we need more constructs, by the way, more programming construct. Carrots. Now we are just collecting wood. Let's see. Okay. We have increased the farm size by quite a lot. By 2 columns. Okay, we have the range, classic Python method. Range, you put a number, you get a range object in return. But I don't think that we need a range here. Show the hint. Okay, we have get word size. Get word size. So we can actually what is get word size, by the way? Let me see. Get word size. Get the current size of the farm. Return the side length of the grid in the north to south direction. Okay, so it actually gives us the for example, the maximum y or x that we can reach. Let's right click on it just to read the full. Okay. 1 tick to execute. I don't know about the ticks, but if they are important or not. Okay, so we need we can have the global size of the farm, right? Let's try with I don't know. How can we actually move? Because what we need to do now is to actually say, okay, bro, just for every column in this farm, we need to do stuff on every row of this farm, but then we need to repeat, and we can't create actually function now. I think we can't create functions, right? Yes, functions are okay, they are a bit away. This is weird, guys, by the way. This is freaking weird. We can't create function now, so we need to stay maybe, I don't know if I can say procedural, but we need to stay in the same scope. Alright, get word size. So now we can check the size. I don't think that this is actually important, because I assume that when you move to the right in the third column here, you will just return to 0. Probably you can call the clear in this case. This could be a good idea. Okay. I have an idea. So but I can't check. Okay, I have the worst size, but I can check the yes row and column. Ah, okay. This is cool. This is cool. So okay, we don't have the drone position, but we can actually iterate. Through rows and columns, right? Let's stick to. We can say RC. Mm. And we move east. Size. Ah, we don't have variables. Yoink, lol. So we can just do something like this. Nope. All right. And it stops. And now should be fully automated. Okay, but now we are just collecting wood. Let me see. Yes, we're just collecting wood. And with wood, we can actually unlock carrots. But we can also collect the unlock the debug. But debug is not important for me now. Let's unlock the carrots. Alright, so before you can plant carrots with plant entities.carrot, you have to till the soil. Remember to drink, guys, always. Never stop. Okay, so we need to till the soil. Okay, because we have two types of soil. Of ground. We have the soil and the grassland. Grassland, I think that is the yellow one. Soil is the soiled one. The tilled one. Planting carrots costs wood and hay. Okay. This item will be automatically removed when calling plant entities.carrot. The problem is that here we are just collecting wood. We don't have a way to switch between plants because we don't have we don't have the position of the drone. We could use, for example, a counter, but maybe it's not necessary. We can water, but I think that is not necessary. We can increase the carrots yield. I don't trust the debug, but let's unlock the debug. Wait, what is this? Let's unlock the debug. Okay, we can set breakpoints. And we can print stuff. But print is low. Print is pretty low. Slow. Quick print is quick, and it will print the in an output.txt. So this okay, this file here. All right. So we can actually but this is not my issue now. You know what we can probably do? We can say that just for even position, we plant bushes, and in odd position, we plant grass or carrots. First of all, let's think about the bushes. And we can do this reason by row and by column. Let's stop a bit this mess. Okay, so now we are iterating through everything. We can probably say we have 3 entities now: grass, bush, and carrots. Let's create. We don't have variables, right? So we have to make this shit in the here, in the scope, the for scope, the for suite. So c is an integer. So if we don't have the modulus operator, I think. We don't have the modulus operator. For now, we have to maybe to stick to one plant, I think, because we don't have the operators. Okay, wait. Let's return to the. Let's remove this. Let's return to the grass, because we need to actually unlock some stuff here. Variables and functions will be really useful. Yes, I think that our next upgrade will be operators and this stuff here. I needed the operators badly. By the way, guys, I love these programming games because they are usually simple, but they require a bit of reasoning, right? They are actually they allow you to solve actual problems. Waiting. Can we increase the grass yield? But we will lose 300 of them, and we need for the operator. So slow. Because actually we don't have a way to say, for example, if the column number is even, we plant another thing, because I think that will crash. Maybe I'm wrong. I'm totally wrong. Let's make a test. Okay, we don't have the operator, right? I imagine correctly. So we need to wait for a bit. Arithmetic operator. I'm tempted to go for the grass yielding improvement, because we'll increase the actually no, will diminish the time that all this shit require. So we'll go for that. But the drone is low. I made a bad mistake. The drone is low. But no, wait, we increased the yield, so we actually getting the double, almost double the grass as before. So this was actually a good move. We don't care about watering on other plants for now. We just need to increase our logical possibilities. So the next one will be this for sure. The farmer was replaced. The farmer was replaced. Yes, this is the name of the game. Yoink. Let's broke the goddamn wheel. I'm so stuck with this phrase, by the way. Okay. We now have operators. So we have the modulus and so on. This will help us to actually automate to switch between plants. Okay. So now we can say, okay, the harvest part will remain the same, but if C is even, we actually plant the bushes. Okay, let's try this. Okay, so this is the second column here. So we start from 1 actually. Ah no, yes, is yes, I wrong the wait. I made the wrong condition. Okay, now it's correct. So we start from 0, 0, 1, 2. But what I want, let's hard code it a bit. We don't have continue, so we will need to make something like this. If it is 0, we plant the bushes. If it's modulus 2, we plant the carrots. And otherwise, we do nothing otherwise. This should plant everything. Not the carrot. I don't see the carrot. Ah, wait. We are not planting the carrots. I expected that the carrots will be planted in the last row, right? So let's yes, let's try the print. Yes, but it's not planting actually the carrot. Ah, yes, sorry, because the carrots needs the tilled soil, right? So we need to till. But we don't know ground types. We don't have the ground types. Let's try. Oh, okay. We are lucky that the carrots. No, it's not working. It's not working because he's tilling the already tilled soil. Wait. Yes, this is a logical issue because if you are in the third row, so when c is equal to is even and is not 0, we are actually tilling, but the issue is that the carrots are not already. We needed to take the carrots first of all. So this logic here is a bit messy. What we need to do actually, we need to check if we can harvest and harvest, if we can plant and what to plant. But how can we check if we can plant? We can't. We can't. So we are actually overwriting the carrot. You know what? Let me make something not good, but not perfect. But we will improve it later when we unlock new stuff. If we will unlock the correct stuff. Okay, if can harvest, we harvest. Let's do a flip to wait some time. This is so hard coded, but who cares? And is working fine. Is working like a charm. Oh yes, this is what we want. This is totally perfect, but bushish. Okay, we are not. Yes, we are not taking bushes for the same reason, I think. We need this part here, even above. We don't have variables, so we can't make. Let's hard code everything for now. But this should be the solution. Extremely slow. Maybe you can remove the flip here. Maybe it's not necessary. Okay. Now we are taking everything. Let's see the next unlocking part. We need okay, senses. All right. This is quite useful. Now we can get the drone's position, and rows and columns start from 0 and increase by 1 each time you move, for example, to north for the y-axis. Okay, is intuitive. Num items returns how many items you have. Okay, this is a kind of we could probably implement a kind of AI statement in the future. For example, checking if we have less than 200 for a certain item, we can just plant a lot of them. Get entity type and get ground type. Okay, this is very important. We can just improve a bit here. Okay, so now we can check the ground. So we can just keep this do a flip. We can even increase the efficiency of this plant. So okay, if we can harvest, we harvest. But if the ground, if get ground type is different from grounds.soil, we actually till. So we don't have to wait, and we don't have to till in many times. This should improve. Yes, okay, but now we are not waiting for the plant to fully grow. Okay, now we have also looked at the none. Ah, okay, get entity type. So probably you can say let's quick print the entity type, the get entity type. I want to see the. Do we have okay, documentation here? Let's try. But we need the console here. The here, the output. Okay. Okay, this is quite useful. No, okay, this is not useful because we need to find a way now to say okay, the plant has fully grown, but we don't have this possibility seems now. Wait. Let me see if I can unlock something else. Variables which are fucking useful. We need to. You know what? Probably with a flip. Every time we skip a row, with a flip we can just get the right timing for the plants. Because the issue with the plant is that we need to plant them only if we have already harvested them. Okay. Let's do a flip. Classic developer experience. Okay, this will buy us some times to let the carrots grow. And is working. Yes, it's working. It's totally working. Okay, now we have solved this problem by making like a temporary stuff. Okay, we need. Okay, now we are about to unlocking variables, so we can simplify even further. All right. Okay, now we can appreciate the for loop. Wait. Let me see just a second. So for the for loop, the question is probably that now we can use the I. Okay, so we can use the I on in the same loop, in the same scope. Okay, we can also abbreviate the operators forms to automatically assign in a operation in place. All right, so now we have variables. Let's refactor a bit this all this part here. Okay, so first of all, if we can harvest, we actually harvest first. Then we check our position and we plant accordingly. Here we have a problem. We are duplicating the can harvest, which should not be the case, right? So let's just delete the harvest, because we are already harvesting in at the start of the loop. If we need to duplicate the harvest, we probably are making some mistakes, right? Because we are making a timing mistake. So this should be an improvement. And if get ground type is different from soil, we till, which is okay. We don't need to quick print anymore for now. And now we have a wait. Okay, we are half an hour in, so we'll make another half an hour. This is just an experiment, guys. It's the first time that I play a game where you code on the fly, so is could be cool. For now, we can just continue like that, I think. I don't like the do a flip. We can probably just improve. No, okay, the time is almost almost perfect. We can't remove. We can do a flip maybe just when we are in a even column. We can try this. Wait, this is wrong, by the way. For every column, because we are moving by column, right? So, yes, we need to modify this part here. All right, maybe this will skip some one actually flip. Okay, and is perfect. Is actually perfect. Okay, this is seems the most efficient things that we can get. All right, now we need probably functions. Oh yes. Okay, functions. We need we have a function. We can have default values. Okay, we have also scopes, but we will come to that. Oh, I lost the function part. Functions. Okay, we have harvest function definition. We can create a function that let us move by n times. Oh, wait. When you use a def function, you should really think of it as a variable assignment like this. Function equal and the function create a new function object. So we can't actually use the function before it is defined. Okay. I think that probably we will learn more about it in the scope section. So we can't do this. Because I don't know, we have the main here. If I open a new window, I create a new file, but what is the scope? If I call a function from the main, can I see another file? Or I need to assign it before, I don't know. Okay, we can return values. We have tuples, which is a way to return multiple values. Default argument, advent. Okay, we can actually create closures, so function inside other functions. So here we are actually executing f, and f return a d, and d return a function. So we're actually d execute a function, doesn't return any function. So we need to call f to get d. So here we are getting d, and then we execute d, which perform a flip. Okay, here he's making something interesting. So you pass a function as argument, and so we are actually abstracting the function body. You pass the function and its argument, and it will perform the function with its argument. I don't know. Maybe it's not a good idea for now. We don't need interface, right? And tuples. Okay. So now we have tuples. Wait, but let's just see the tuple because I'm not sure that there are the normal Python tuples. Okay, normal Python tuples seems. Okay, there are the normal Python tuple. Okay, let's try to create a function, right? Because this is probably the fun part. Obviously, at the end of the stream, obviously. Okay, first of all, how can we design this part here? Okay, I just see like two patterns, right? We have the planting phase and the moving phase. For now, we can just move out the planting structure. From design level, probably would be better if we leave the check over the row and column inside the loop, so it's clear. But since we don't need to do many things inside each if, maybe it's not useful to create different functions. The function, the only useful function, as I'm seeing now, probably would be the carrots function. But I presume that in the future we will plant in soil different plants, right? So we need to create maybe a function that accepts two arguments. The first one will be the entity's name. The second one will be a boolean, right? If we need to till those this entity or not. So we can create our own plant function. Which will accept an entity and a boolean to tell us if we need to till the soil or not. I don't know internal, but maybe it's too verbose. Don't know. This editor is not really. See, I'm not going to words. Entities dot bash, and here we have entities dot carrots. Okay, let's define the function. let's try another block. We have the entity and if we till or not. We don't have type of notation for sure, so let's just continue like this. Oh, I opened the Steam for a bit. I hate this editor, but it's not that bad. I mean, maybe I'm just not the best guy to using it. Okay, plant internal. So if the type, no wait, if so now we can just say so if t and so if we want to soil and the ground is different from the soil part, we just till and plant. Otherwise, we just plant. Yes, this is what we want. Let's see. Okay, it's never been defined. How can we import? Wait, we can import the stuff. Let's see the scope documentation. This is the part where we need to know about the scope. Okay, there is the function scope, the global keyword. Okay, inside the function we need to use the global. But we don't know about the... So we needed to assign the function before using it. So we can probably overwrite the plant, right? But overwriting the plant is not a good idea, because we need the plant function inside the plant internal. So we can say p. Something like this. Probably should work. I don't like this construct, but if is the only way, yes, import doesn't exist. Impo. And we can't use these things right here. The import doc package. But I think this was a... Correct me if I'm wrong, but I think that this is actually a a Python warning, right? Python error, Python exception. Import, wait. So we have the import here. Cool. Okay, each Windows in the game is a file. Oh, okay. So it's pretty simple. So we can say import F0. We don't need this part here. And we can just replace the farmer, I guess. The goddamn wheel. The goddamn wheel, guys. Alright, this we don't have import. What? Oh no. We need to unlock import. So how can we use the... We can't. We actually can't. We need to define the function before our main loop. That's it. Unfortunately. Alright, who cares? For now we'll be good. Okay, we are not planting any bushes. Ah, yes, because I'm stupid. Because I need to put the... E stands for entity, right? Alright, now it's working fine, as we expected. From an efficiency standpoint, it's not a good idea to dispose things in columns, as we are doing now. In rows, sorry. Because as you can see, bushes grow faster than carrots. So we probably need to have a column full of, for example, bushes, and a column full of... So we need to flip the logic. So we need to reason by column and not by row. Let's remove this shit for now. So if c is equal 0, we plant bushes. Yes. We don't need to till the soil. And if okay, we stick with the carrots thing. So if is an even column, we plant carrots. Otherwise, we leave it to the grass. So we don't need this part here anymore. And we harvest each slot. Let's try this logic. Alright, yeah. This is weird. This is totally unexpected. This is expected actually, because we are checking the starting of the column just in the first stage, the first loop. Okay, we needed to move this part here in the... Yes, we will probably just need to switch the variables from row to cols, but it's cool to making mistake live, which is probably fucking normal. Probably. Okay. Okay, now is not efficient. Okay, now it's working fine. It's actually working as we expected. This is cool. This is pretty cool. Okay, we have 10 minutes. What we can do in 10 minutes? We can probably unlock, we can increase the yield of the grass, for example, which is really important. Seems like a base resource, right? We can increase the speed of the drone, which is important. And we can actually expand our farm. We should be fine. And the carrots yield. It's working weird. Yes, because he is actually leaving to the grass the... wait. Let's reset the code. Probably this was the issue. Alright. Okay, it just works fine for now. But we don't have enough wood, it seems. We need probably trees. We are not planting enough bushes. Seems. Okay, no, they are increasing actually. All right, so we are fine with that. But we don't have the yield of the wood. Okay, we can actually indefinitely expand our farm yield, our grass yield. We don't need the watering, I think. Okay, list, which for now are not useful, and utilities, which for now maybe are not useful. Okay, maybe it could be useful, but with the list. All right. It's actually working fine now. I don't know about the tilling part, because now it's working actually. If the carrots are not fully grown, it will just skip. I don't know where is the fix, because I haven't changed anything actually. Seems that get ground type is not the soil if the plant has not been grown fully. So we can just probably quick print just to check the get ground type, right? Just to be sure. So output here. Okay, is what we expected. He's actually skipping the... He's actually skipping the... yes, because it's already soiled the ground, so we don't need to soil it again. Okay, this was the fix. Okay, stupid as fix, as always, as usual. So, alright. The issue is here is that we're not producing enough wood. We will probably need to upgrade to get the trees, which are at this point, I think, which are the improved version of the bushes, which is cool. Remember to drink, guys. Always remember, bro. 0 effort, many benefits. You know what? We can probably even we can probably say just fuck you carrots. Let's just print the bushes. We just need wood now, so. Alright. Okay. Trees are better than bushes. They give 5 wood each. They can be planted on grass or soil. 3 like to have some space, and planting them next to each other will slow down their growth. The growing time is doubled for each tree that is on a tile directly to north, east, west. Okay, in a direct tile. So if you plant trees on every tile, they will take 4 times the longer to grow. Let's show the hint. I don't care about cheating. The modulus operator could be useful. Yes, we can actually alternate the trees. But okay, so we need to alternate the trees in the bushes column, right? So let's just say, okay, bro, here we want carrots there, I think. I don't remember anymore, but is okay. And so we need to check. So if R is even, we plant a bush, for example. Otherwise, we just plant a trees. This should do, actually. Alright, it's working fine. It's working almost fine because we are actually many grass. We don't want the grass. Yes, wait, we want the grass. Okay, it's okay, it's okay. Ah, yes, and the trees are upgradable with grass, which is quite fucking cool, which is what we really want now, because we can actually increase a lot the efficiency of the farm like this. With 2 trees, we can actually just say, bro, they are like 10 bushes, bro. 10 fucking bushes. But wait, how much they cost? Nothing. They cost nothing. Okay, we needed to increase the yield again. Okay, investing in grass yield is was quite useful. Okay, guys, another 5 minutes, I think, and we will probably quit this game. Okay, let's speed up a bit. Okay, we have a lot of food now, so we can increase the yield and the cost of the carrots, which could be useful. Yes, now in this part is probably just an optimization phase. We have maybe too much grass, but for now it's cool, because grass is the base resource. We need probably to increase the size. This is what we need. And to increase the size, we need actually to plant pumpkins. You know what? Let's add the pumpkin. Alright. Pumpkin. So now we probably will need to say, okay, in the even column we plant bush. In other columns we plant trees. Rows, sorry. In the at the 0 we plant bush and trees. Okay, let's say something like, let's revert everything. If is an even column, we plant bushes or trees. If is not, we plant carrots. But we want to say also, if the column is 0, we plant pumpkin. But pumpkin, okay, let's stick with it. They don't need the soil, I think, or I don't know. Untilled soil. Okay, so we need to soil the pumpkin. Ooh, okay. Yes, now obviously we don't have the grass space, but it's okay. Yeah. We need to increase the size, by the way. And this will require us 200 pumpkins, but they are so slow, bro. So fucking slow. Because we have five resources, I think, right now. Yeah. No, I'm just wrong. I don't like to hard code this stuff, but I think that in this case we will probably need to do it. Unfortunately. So if it's equal 1, we plant the wood. If it's equal 2, we plant the carrots, and otherwise we do the grass. We need to hard code it. By the way, you know what? Now we need just pumpkin. Let's just place them in place of the carrots. It's not a great idea because I think that pumpkin cost carrots. So we will finish eventually all the carrots. And I think that pumpkins are actually take advantage of being near each other, right? Alright. So grows like exponentially. I don't know the growing curve, but yes. It's a good idea probably to increase the size with the pumpkins, yeah. We are almost there. 10 minutes, we are about to, I think, to close, guys. I think. Today was an experiment. I think that I will just leave it as a stream, this part here. All right. Now we can deal with more stuff. You know what? Let's see. If we are like, if the pumpkin is less than, we can say 1 for now. We plant pumpkin. Otherwise, we continue with our. Probably less than was a mistake because now we need to plant to change everything. But who cares? All right. This should create exactly. All right. Now it's working fine. Huge fucking pumpkins. But there is another issue, I think. Since we have increased the pumpkin yield, now we need more carrots. And I have an idea for that. For this. You know what? We can actually say, bro. We can actually create a new function that will say alternate with trees. We accept is the same actually as plant internal, but we will need we will require a new argument, which is the row cell, right? So this will actually say so. Mm. All right. Let's say, because we need also to specify if we want them on the even or on the odd side. So we are actually saying, okay, if is even and the actual row most 2 is equal 0. So if we have an even situation, we just plant internal the entity. You know what? Not the entity. The tree without tilling. But I'm thinking, because this is quite complex, maybe logic. Okay, if you are in an even situation and we are in a really even column, we just plant the tree. Okay, if we don't want the even and r is mod 3, is if r mod 2 is the basically is odd, here we want to plant also the tree. Otherwise, we plant the normal type. This should actually do. So now we can use this function in place of this. To say wait, we can say alternate. We don't have the completion here, the code completion. Okay, we alternate with the tree. So we pass the entity, which is the bush. We pass the tilde, which is false, and we pass the row, and we pass. We want them in the even rows cells, and we can actually cancel all this part here. Even this part here, actually. All right, this is better. And we do this also with the carrots. But this time we will say not even, sorry, is true. This will be false. And I think that we made quite an improvement here. We will see. Okay, this is an error. There is an error. Plant internal ET. Okay, it's not working for the carrots, but it's working perfectly fine with the bushes. You can see my dog, my little Yorkie. So if it's not even, the row is not even, and the actual row that you passed is not even, we plant the tree, which should work actually. Yes, this is an error, by the way. We will overriding probably the carrots with the carrots. Yes, now it's working fine. All right, we made quite an improvement. We will probably need a dictionary in the future, because now we are actually not planting any carrots. We needed to increase the carrots yield like a lot to compensate. Okay, guys. By the way, this is the first part of this game. I think that was kind of fun, quite fun. We created quite a bit of logic, and we are not actually using any file for now. In the future, we will see probably. Yes, we will continue. I think this series, but yeah, I think that we are almost in the middle of the game actually. So will just be a 2 episode. So, guys, hope you like this freaking stream. Go to watch something better than me, I guess. So, see ya, brother, from bersipy.